We are coming now to the last talk of our today's meeting, and it's again an invited talk, and it will be given by Martin Krzywinski. I hope I pronounce the name at least partially right. So I saw him somewhere here in the participants list, so he is around. So Martin is working at the Michael Smith Genome Sciences Centre in Canada. So for him, it's really, really early, and I'm happy that he joined anyways to give a talk here. So Martin has been integral part of this center since its very beginnings in 1999, shortly after completing his master's degrees in medical physics. So altogether, Martin is well known for his work in bioinformatics and data visualization at the interface between science and also art. So his information graphics have been appeared among others in the New York Times, Scientific American, and covers numerous books and science journals such as Nature and Genome Research. So we are happy to have him here now, and he will talk about how to tell a story to the eye, design of data graphics. So Martin, you are welcome now to share your screen, and we are curious about your talk.
Hello everyone. Thank you for having me. Are my slides coming through okay?
Yes.
Excellent, all right. One moment, 1 second. I'm gonna move the chat window out of the way. All right. Okay, storytelling. So lots of people have different ideas of what that means, but at the core of it, it certainly means delivering a really good explanation of whatever it is that you're talking about. Often these kinds of explanations involve metaphors. And metaphors are easy. Metaphors make us feel like we can borrow from a statement to simplify the question, the matter, in a way that somebody can understand. And some metaphors are both poetic and true and wonderful, such as anything said by Richard Feynman, or for example, this statement. However, there are some metaphors out there that are absolutely incorrect, such as this statement. And it is not only incorrect, and it's not only commonly seen, but it gives people the exact wrong impression of what it is that you're trying to explain. Now, why is DNA not a blueprint, for example? You might have seen this term. Well, this is a blueprint. What is it a blueprint of? Everybody knows the answer to this. It's a house. This is DNA. What is it a blueprint of? You have no idea. In fact, we don't know how to figure out what this is a blueprint of. We don't know what this animal is. The only reason we know what this animal is because we took it from the animal. But there's no way of figuring out what this animal looks like from the sequence. So no matter how many visualizations of genomes you create, you will never, ever be able to, at least not yet, show this or this. This is a single stroke of Picasso's pen that tells you not much about the biochemistry of the wiener dog, but perhaps a little bit of the things that are very difficult to get from the genome, which is the unusual shape, and certainly from a photograph, maybe the dog's personality. And so you have to be very careful when you use metaphors because you stand the risk of losing, excising a tremendous amount of what is essential to the thing. And one of the difficulties about the genome is that we don't know how to connect the genotype, which is the genome, to the phenotype, which is what the organism looks like. The phenotype includes things like symptoms of disease. So we don't know specifically what would happen if I change this letter in the genome. How will that affect the organism? This conversation is fairly relevant around COVID these days about mutations in variants. What does this mutation, what will it do? We don't always know. So what would be the right explanation for what a genome is? What would be the right metaphor? The genome is really a set of tools. This is your home's genome. It's just a set of tools that were used to build the home. The tools themselves are not really used up, and the materials from which the home is built are not in the genome. It's the tools. So these correspond to enzymes. These correspond to the chemical things that make chemicals at room temperature possible so that the biochemistry in our body can proceed. Now, the problem with, let's say, cancer studying and looking at differences in the genome and how they impact disease is that when we look at a genome that's perhaps a little bit broken, we don't know what the consequences will be necessarily. We have to really look into it for quite deeply. And so you may have not even noticed what the difference between the healthy home's genome is and this home's genome. Let me switch back and forth, and there you go. So this thing is crooked. Now, do you know what the consequences of this thing being crooked are to the home? You don't know. This is what makes genomes complicated. This is what makes studying genomes hard. And this is what gets lost in the statement that a genome is a blueprint. So now once you've said that, you have to backtrack and say, well, really what I meant was quite something different, and start the conversation all over again. And nobody wants to have to start the conversation all over again. When you're making graphics, other than having a good explanation and avoiding bad metaphors, is to try to very quickly communicate why the graphic exists. Why are you showing me something that you've drawn? I should be able to get it from the drawing itself and from the design, not from the title or from the legend. And that's not always obvious how to do it, because you have to have the right question in mind. But for example, why are you looking at this graphic? You have no idea, right? This is a commonly found type of graphic. You know, it's in a paper, it's in a poster, I'm staring at it. I don't know what I'm supposed to get. Is it the height of the peaks? Is it the fact that there's two peaks here and there's one here? I don't know. So how can I help the viewer focus on the things that are important without using words to say what is important? Well, if I, for example, make the second peaks blue, you now know I'm probably talking about those second peaks. Am I talking about the height of the peaks? But what if I'm talking about the area of the peaks? What if I'm talking about the area of the ratios of the peaks between the control and this compound? If I do something like this, then you realize, oh, I think he's talking about the areas. Then if I do something like this, then you're like, oh, he wants you to compare the areas. And then if I do something like this in the last column, which is divide the areas together, then you realize, oh, it's the ratios of the areas. And you right away know why this graphic exists. I don't have to tell you anything. I can have a very short legend, which saves me space. Maybe in a journal, you can't get away with this because you have to have a lengthier legend. But in a poster where you're standing right beside it, or you're having a conversation about something in an interactive way, this can be very powerful. Why am I looking at this graphic? I don't know. What am I supposed to get out of this graphic? I don't know. I'm waiting for myself as a speaker of giving a talk to tell you, right? Well, what if I drew just the profiles like this? Suddenly you realize, oh, wait a minute. They're similar in some way. They seem to be ordered. Oh, this peak goes up. I see. And this one is really quite different. So sometimes by just starting with the trends and reordering things and not just counting on the software to give you the right order, you can very powerfully cue the eyes to what is important and then fill in the details. So for example, I mean, those were levels of pigment across years. Doesn't really matter what these curves are. They could really be anything. Right? But let's say the year 2000 is important because that's where there's a dip there in quite a lot of these profiles. So I would draw the year 2000. I would put a dashed line at every profile, not repeating 2000 everywhere. It's obviously that's what that means. And then if I wanted to cue the fact that I'm interested in the position of this valley relative to the year 2000, I would do something like this. I would draw the peak in red where it stops, the red would stop, and then I would draw a bar to the left, blue, or to the right, red, of that vertical line. And so if that valley happened before the year 2000, it's blue. If it happened after the year 2000, it's red. Right? Whatever, let's say that that's important. This is just an example. The purpose of this graphic is clear. I don't have to explain it to you. You'd be looking at the blues. You'd be right away expecting me to say something about why these things are early. You'd be maybe expecting me to say about why this is so late, and so on. Oh dear, it's way too early in the morning for this picture. So you probably have seen it. And this is one of the early COVID graphics. Where is the story in this graphic? There's no story in this graphic whatsoever. There's something that's missing, critically missing. Yes, you know, there's gonna more deaths. Yes, but why? Why would there be more deaths? We want fewer deaths, but why are there more deaths? The thing that's missing from this graphic, and you probably know what's missing from this graphic because you've seen this graphic fixed 1,000,000 times, is this line. Right? That is the critical line that tells the story. Basically, it says, thou shalt not pass this line. And if you do, then there be dragons there. And why didn't they include this line? Your guess is as good as mine. Neither I nor anyone else really understands US politics. Now, we don't have a different problem in British Columbia. We get daily reports about COVID and we get daily graphics that look like this. What's the purpose of this graphic? It's already too late, right? This daily report, it's an hour, it's a bunch of slides. People are tired, they're trying to read your legend. These legends are almost identical. The colors make no sense. The title, for example, the implications of dynamic models in BC's context tells me nothing. Just tell me what the implications are. That's one of the things you could really do to increase the quality of life of your audience. Just tell me what you found right away. Don't start with introduction, background. Just give me the conclusion. I'm going to believe that that's what you found, and then I'm going to look for some data to prove it. But please start with the most interesting thing. So what's this graphic about? You don't know. So let's see if we could figure it out, right? What happens is there's a certain amount of social restriction, social distancing. And if we relax that social distancing, so if the contact level of normal goes back up to 100% of normal, no mitigation, cases go up. Cases go up exponentially as opposed to they don't go up. And so what we're interested in is this line right here. What is the maximum amount of returning back to normal that we can have without that our not value going higher than 1, without the epidemic essentially becoming an epidemic or returning to an epidemic. And so I would draw something like this. Why magenta bad? The color of disease and blood, blue good. The color of relaxation and yoga. And this is the maximum tolerable percent of normal contact level. This number did not appear in the original graphic, which was the one question that everybody has in mind. To what extent can we return back to normal? We can return back to 62% of normal from the current 30. That's the answer. You couldn't get that from that graphic. Again, why was that graphic not fixed? I don't know. People are busy. People are tired. People are not really thinking of what is the question in the reader's mind and what does the eye want to see to answer that question. Classic Lewis Carroll quote, stories have a beginning and they have an end. There is generally a time flow in a story, unless you like Memento, in which case it goes backwards. But generally there is a serial process of events. And it's wise to think about it, and it's wise to at least respect that and borrow from it, because the eye and the mind kind of understands cause and effect. So here's a graphic someone sent me. They began really quite solidly with 2 lines that correspond to the cellular membrane. And then it got out of hand, right? Then it's like, what is the order of things here? After I finished hunting for 1, 2, 3, 4, I hope you found 1, 2, 3, 4. Oh, did you find a 5? There's a 5 here. You realize what is happening here? What is first? Things seem to be numbered, but I can't figure out how they relate to one another. Everything is just not the way it should be. So what should you do? You shouldn't do this. And this isn't just a question of, I don't know how to use Illustrator and I only know how to use PowerPoint, and so this is the best that I could do. Because it's you certainly know how to move text around on the board, on the artboard. You probably know how to change the color of things, and that will save your life and will save other people's eyes as well. So we start with nuclear membrane, plasma membrane, okay? And then we set up some kind of a track of events. Pretty easy to follow, nicely labeled. We throw in a bunch of stuff. And it's very ordered. The color is only limited to the things that are either down-regulated or up-regulated. And we're done. Now, if you notice, there's a couple of things that we could fix here. One, this legend is really quite far from where these colors appear. So we're going to move that a little bit closer. One of the things about legends is that they often tend to be very far away from the thing that they're labeling. And often they're completely unnecessary because those labels can be worked into the graphic. Second, you may know this Gestalt theory about foreground and background, and there isn't a very good sense of the inside and outside of things. This is inside the nucleus, but because of this membrane, it's kind of thick, this doesn't really feel like inside of anything. And this is inside the cell, it doesn't really feel like inside the cell. So I would do something like this, where I would actually shade in parts of the graphic to give you a very strong sense of containment. And then there'd be plenty of room for other text, which if it's italics, it's subordinate to Roman, which means that read it at your discretion. It's interpretive text if you have the time, and notice the legend got shoved closer. One of the things that you have to do is, as you're telling your story, as I'm giving this talk, I have to think about, well, what kind of questions might you want to ask? As I'm looking at a slide, I have to try to think of it from somebody else's point of view, of what might come to their mind, and then rework the slide to try to lead their thoughts down the road that I would like them to take. Obviously, I want you to take all sorts of roads, but there's a couple of paths that I think are a little bit more productive, at least on the first pass. So I made this poster once because I was fascinated when I learned about the Booty's void. So in the universe, there are these things called underdense regions where there is less matter than statistically would be probable if things were kind of randomly spread out. The Booty's void is about 700 million light years away from here, but it's 300 million light years in diameter of nothing, like literally no matter. There's a couple of atoms, but there's nothing. And so it's a very lonely place. Now, it turns out that the universe is full of these voids, these holes where there's nothing. There's something called the Ariadne supervoid, and then there's thousands of voids. And I thought I'd love to make a giant map of nothing. So I made this map of nothing. I added in some superclusters of where galaxies clump. These are not stars, these are galaxies. What you're looking at is the actual entire visible universe. Threw in some stars, threw in some constellations, and then the whole thing wound up in a poster. Now there's a crap ton of things here, and there's a lot of technical details that a lot of people may not be familiar with. So you can kind of see that there's a bunch of stories around the edges, and at your leisure, you can explore these. Now, what kinds of stories would I want to tell you? What kinds of things might I anticipate you want to know? Let's say you know nothing about space, right? You look up at the stars and you know those points in the sky are stars, but you don't know much more than that. So we would start by, let's say, talking about the Bright Star catalog of Yale's Bright Star catalog. There's about 10,000 stars. Here they are. And here's a couple of stories about constellations and Orion and Canis Minor and Scorpio and so on. It's mythology, right? It's great. Then we would talk about, oh, and here are the constellations. This is the same orientation as what you're seeing in the big poster. So you get a sense of kind of where things are. You can find your own favorite constellation, and here you see Polaris and so on. Then you would realize, oh, what is this galactic equator and supergalactic equator? What is a supergalactic? Are we in a super galaxy? What is that? So then we talk about 3 kinds of coordinate systems that we use to find things in the sky. We use the equatorial system. Basically, we put Polaris at the top because we're self-centered on Earth. We use the galactic system where the plane of the galaxy is the equator. And then we use the supergalactic system where we're no longer just talking about our galaxy, but we're talking about the universe. And so we use the plane of the cluster of our local galaxies. And so here you see how they relate to each other. So Polaris is over here, Polaris is over here, Polaris is over here, and you can find your way. That's the caption, right? Find your way around. Next thing, you learn about how to read the map, and then you have this thing about further than you think. In other words, there is this perception that because the universe is now 14 billion years old, it must be 14 billion light years in radius. Well, actually, it turns out that it's not true. Even though the age of the universe is 14 billion years, the radius of the visible universe is actually closer to 50. And that's because space is stretching while light is traveling to us. It's called co-moving distance. And there's a bunch of plots about this. And so you just get this idea, it's like, oh, it's a lot further. The thing I'm looking at is actually 3 times further than I maybe originally thought. Then you have some accounting of some of the big holes, the closest nothing, which you might want to know about. It's like, well, where is the closest nothing? Nothing out of nothing. These kinds of turns of phrase that you have to be careful not to be too cheeky, but try to kind of encourage the eye and use words that are maybe a little bit poetic, maybe a little bit punny, to make it interesting, to make it like you care. There's a river in the sky, so Ariadnes is a constellation, it's named after a river, so there's a super void, it's a giant void, etc., etc. There's, it's very large and there's things to be said about it. Finally, you might look at, say, well, here's the furthest thing that we have ever measured. And then you feel like, well, I've just talked about a whole bunch of nothing. So I should probably, you know, and feeling this feeling, perhaps some existential dread, perhaps this lack of relevance in this giant universe, whatever. So throw in a poem that makes you feel even sadder, and yet find some hope. Create a place on account of us, that maybe it's the very short distances between people that matter and not the great distances across the universe. This is critical. I have seen stories told endlessly many times. They often lack a poetic dimension. Do not be afraid to exercise your role as a feeling, emotional person with connections to others, and imbue your science and your explanations with those feelings with a poem. Make sure it's good. Make sure that it rises to the quality of your science and whatever you're talking about. One of my favorite quotes, this one, because it's 3 words that I think we cannot live without. So every year, I give myself this task to create art based on the digits of pi. So pi is transcendental number, it's this one. It's essentially normal. In other words, the digits are essentially sampled from a random process, almost. So as you see that it goes all the way up to 6 nines, and that 6 nines is a very special place in pi. It was named after Richard Feynman. He comes up twice now because he is just such an awesome person. And here's another explanation of what math is, which is completely true and amazing. And it nails what math is, at least the mechanical arithmetic aspects of it. Absolutely right. So a couple of years, many years ago, I made some posters. So, you know, pi is about round things. So here's a bunch of round things, arranged in a square because, you know, square, round, etc. There's a couple of interesting observations that you can make about pi, such as that pi, the natural logarithm, and the golden ratio are almost Pythagorean. And I'm surprised there isn't a conspiracy theory around this, because I've had lots of people contact me and trying to prove to me that pi is in fact 3 and not 3.14 and so on. So I had to let them know that this should be looked into. But I wanted to do something poetic, and I wanted to do something that connected with my love of the universe and space, i.e. getting off this planet. So I wanted to make a star chart based on the digits of pi, where the digits of pi were interpreted as a star catalog. So that star chart started to look like this. And there's a website about it. You could learn about different projections. And I drew the constellations. And I, for the longest time, could not figure out what should be the constellations in this star chart, right? This was, I knew, the opportunity to screw up this poster completely if I were to do something boring and expected. Mathematicians use some fancy computer algorithm to select shapes according to some fitness function. This is dull beyond repair, really. My eyes are glazing over just thinking about it. So I had this thought eventually, after weeks literally of painting over it, is, well, what are the constellations in the sky now? Well, they're mythological creatures that never existed. Well, why should they get the respect of the sky? What about all the extinct creatures that we owe our genetic inheritance to? Maybe we should put them up there. And so that's what I did. So the constellations wind up being extinct animals, plants, and in a couple of cases, bacteria. You'll see all sorts of stories and creatures here. So for example, here's the bird section and the ducks. And everybody has their own mythology. So Campter flew long and far to find a pond without ducks on Earth, but could not find such a pond. So she flew to settle in the sky. And you'll immediately feel a connection to this poor duck that had to fly to the sky. There is Megalodon, the giant shark, and it's the brightest star in this hypothetical sky. And so he uses it to chase its prey. And then fleeing is the Rhodocetus. And so there's a story about how he fled the water and lived his life on the land, never returning to the sea, because in fact he has mammal characteristics, and it's thought that this was one of the ancestors that made it to the land. There is Tecopa, who is able to swim in hot water, so the fish can evade the shark. And so you've just learned something about Tecopa. There is no North Star, but there is the South Star, and there is this Basilosaurus, who is this king lizard who is diving, to try to reach the South Star. And you're thinking about these stories about what these constellations might mean. Here is Papilla, which is a flocking constellation. So it's the one constellation that's not really joined up because it's a flock of birds. And he's like, well, how come we don't have constellations of flocks of birds? How come all the asterisms for constellations are connected? They don't have to be. And finally, right at the top, why is it at the top? Because it's this giant bat. And he flutters up to the top and he tries to escape the dome of the sky. All of these stories, I think, get you not only closer to things that really lived on this planet, but make you perhaps look at the sky and want more than just Ursa Major, and Orion, as great as those stories are. So the website is it acts as a star catalog really for this hypothetical sky. It's formatted in a way that you would have catalogs formatted. There's magnitude information, and there is some links to the the Tasmanian tiger, died, or last one died in 1936. And there's some humor there and so on. And the idea is, I love this project and I want to demonstrate that I love this project too, because I think when you demonstrate your love for something, other people are more likely to love it. This is another one of my favorite quotes, and I think about it often when I open my mouth, because no matter how important education is, and no matter how important science is, and it's very important because it solves lots of good problems, lots of difficult problems, we have to maintain ourselves in the loop. We have to stay close to the things we feel about what we think, and think about what we feel, and have that go back and forth. So the city of Vancouver was putting up some signs where we're renovating a street near the hospital that wanted to point to the hospital. Right? So these signs are going to be very big, and they wanted to make them kind of look something like this. Here are the signs, here are the final signs, like this. They're very large. They kind of look like some kind of a warp gate, where if you walk through it, you go to some other universe, but alas, I've done it, you don't. And they said, well, we have some room for some art. And here they threw together some kind of electrophoresis gel on it and said, well, what do you think? And I said, this is a bad idea, because 20 years ago we were doing this and we no longer do this. And it would be an embarrassment for us to have that ancient technology, ancient imaging modality displayed on a sign pointing to the Genome Center or to any health center, where really the understanding of biology is much more fundamental than it was 20 years ago, 40 years ago. And now we do genomics. Now we look at the genome and we try to figure out what the problem is. So I thought, well, what are we going to do? How are we going to put something up on these signs that will survive for the next 50 years? In other words, that I don't think fundamentally the way we look at patients, the way we look at, say, cancer will completely change. We'll have more therapies, but the way we look at cancer will always be based from a genomics point of view, I think. I hope to be wrong. So I thought, well, let's just put up real patient data. We do this, we sequence cancers, we sequence hard to treat cancers. So why don't we show the data in a way that doesn't scream data, in a way that says patterns, pretty patterns, the way that doesn't distract the eye, but makes available the story if you choose to look into it. So it's kind of a form of public art, but it doesn't insist that you stand there and understand it, because that's obnoxious. So there's this gene, TP53. It's so-called the guardian of the genome because it protects the cell against cancer. Let's just say that. And we've sequenced this gene many times in patients and seen mutations. Here's the actual reference sequence. The red are the mutations. So what about encoding the bases in some way to make some kind of a pattern, that is attractive but not too distracting? Low maintenance art. So let's call ATGC this way. And so sequence would look something like this. And so here's the sequence and its complement of TP53, just a bunch of half circles. So then what we do is we would put them, let's say, on a grid and kind of make it look like a double helix, where here's the sequence, and some of them are going to be mutated. So that's C, which turned into an A. That's this one, that should have been a C, but it's now an A. And here is the other helix, which is the complement of it. And then what we'll do is, well, we're going to save some space. So if we have a double A, we're going to put a dot there. We can have a triple A, we're going to put a bigger dot there. So now the sequence that's this, where we have 3 Gs, looks like that. So then what we'll do is, along that double helix where the TP53 sequence is, wherever we hit a base that's mutated in this guardian of the genome, we're going to run the sequence of TP53 in the direction pointed by the arrow to the emergency room. Okay, this is really important. It's one of those Easter eggs, one of those things that I've thought about, but nobody's going to notice. But that's okay, because it doesn't matter. But if you do ask, we could talk about how things are transcribed in that direction. And then this, and any time that there is a mutation along that sequence, we drop the sequence of TP53 again. So you can, if you don't know anything about what is being shown, you will eventually realize that the patterns along the double helix have something to do with the patterns along certain lines, and maybe clue in on the fact that they're the same thing. Then finally, what do we do? How do we fill in the rest of the rows? Because the whole thing is a matrix of, I think, something like 40, 25 or 30 rows by 42, something like that. We pick other genes that have been mutated, and we run them along in the direction of the arrow pointed to the emergency room. And where we see a mutation such as this, A to G, we align it with that TP53 helix, so that basically what happens is that the mutation in this gene, that G, falls into the reference sequence of TP53, meaning the story is that the gene saves the cell from this mutation, which it won't, but that's the idea, that it somehow protects the mutation, confers some protection. And so you wind up with a pattern like this, and here's the genes, and there's more, right? If you look at the first letters of the genes, you get this string, and you go, well, what is this string? Well, that kind of looks like BC cancer something or other. And if you remove a few letters, and if you rearrange the spaces, it basically spells out the name of the program that is responsible for sequencing this. So it's an Easter egg. And so this is what the sign looks like in the day. This is what the close-up looks like in the day. This is what the sun looks like at night. It lights up. This is what the close-up looks like at night. And so when people are driving, they're about to make their right or left turn, they look at it and they go, pretty picture, pretty light, whatever, a bunch of circles, who cares, macaroni, that's fine. But they can look a little bit more, and they can ask some questions, and there's a plaque in the back, and this kind of gets them thinking, and it's low maintenance. Have the conversation if you like, keep on driving if you don't. The last story I want to talk about is a really fun one that was a huge challenge, because I don't do animation, and I was forced to do animation, and not forced, I was challenged to do animation about something that was very complicated and very difficult to understand. And so the story is about making the aspects of the theme understood and felt. I was working with Max Cooper, who's an electronic musician out of the UK, and he has this album, Yearning for the Infinite. And one of the tracks was called Aleph 2, which is about a kind of infinity, which is bigger than the first or the second infinity. And he wanted to tell a story about infinity for this audiovisual concert at the Barbican in London, where he would be displaying the video on 8 different surfaces in the Barbican, a couple of thousand people in there. It's this giant music show. He's on the stage orchestrating the whole thing. So how do you tell a story about infinity? Well, you have to overwhelm the audience. You have to hit them with build up from somewhere that they can kind of understand, and then very quickly saturate their senses, because infinity in a way is a little bit of a mind-bending concept. So I won't show you the video, because I'll show you the YouTube link later, because the video is long and loud. But infinity, it isn't necessarily this infinity, which is the infinity I may be familiar with, which is one of magnitude. It's more the infinity of the size of sets. And there is, in fact, an infinite number of infinities. And a really fun example of thinking about infinity, which the video kind of touches on, but in a graphical way, is this thing called Hilbert's Grand Hotel. So it's this special hotel, right? And if I say, well, there's a bunch of free rooms, it's not full, and you say, can I get a room? Of course you can get a room, right? We understand that if the hotel isn't full, you can get a room. Now imagine the Hilbert Hotel is full, completely full. Every room is occupied, and somebody comes to the door and says, do you have a room? Well, this is a special hotel. Yes, they have a room for you. So what they do is they take every guest and they move them to the next room. So if your room is I, you go to room I+1, from room 13 to room 14. Suddenly, the first room becomes available. Now this is possible because the natural numbers are an infinite set. Everybody just moves down one. You never run out of rooms. So the fact that the hotel is full does not imply that no more guests can be accommodated, which is a complete mind bend, but that's how things work. Also, the hotel is full. Let's say an infinite number of people arrive at the hotel and say, do you have room for us? Yes, we do. We just send everybody from I to 2I. So you go from room 13 to 26. Suddenly, an infinite number of rooms have been made available. And an infinite number of people can be accommodated. Yeah, I know, it's crazy. So this video, if you Google Max Cooper Aleph 2, you can watch it. It's 6.5 minutes of heart-pounding mathematics. It's fantastic, and it goes through the proofs, visual proofs of why certain sets are the same, and the problem that you get when you get to the rational, to the reals, and so on. And in my last 5 minutes, I guess I want to encourage you to encourage emotion and spark delight, and that's often not done by people. So, you know, you may work with scientists. I don't know what your backgrounds are, but you go to talks and you get these really dull slides. And I'm not saying that dull slides are a sign of a bad talk, because I've seen bad talks with great slides and I've seen great talks with bad slides, but they generally don't spark delight or emotion. And the first title slide is an opportunity to give people a sense of something magical, because you're not responsible. You haven't started talking about the science. So you're going to talk to me about land snails. Don't just show me what I exactly imagine a snail to be. This is the archetype of a snail. I mean, nothing has been learned by looking at the snail. What if you show me this? This is amazing. Look at these colors. They're wonderful. Are they even from snails? We don't know. Point is, do something different. Here is something about chickens. So the University of Sydney has this really dynamic, energetic orange color. For their branding, great. And then on the right side is the worst possible picture of a place I wouldn't want to visit, because look at it, it's super boring. So what would you do? I just Google chickens and find some kind of a scene of chickens that suggests that they have personality. Maybe she's busy and he's like, what are you doing later? Nothing, not whatever, right? You're wondering, is he coming in? Is he going? Don't put him completely in the frame. Make him look like he's entering and they're having a conversation. So recently I got some mail from them and they have changed. They've got more personality in their picture. This is pretty good, right? So maybe they watched my stuff. Here's a title slide of somebody's talk and those beautiful yeast cells in the back. I want to see more of them. Pump up the color. Do not hide your beautiful photos of amazing things behind a transparency screen. Like this title slide. Oh boy. And then halfway through the talk, you find this. These are amazing. Why wasn't that the title slide? I don't know. Or this. Upper limits on energy non-conservation. Again, there is this thing about faded, beautiful photos in the back. What is this photo in the background? It's a couple of guys, 2 guys in a boat fixing a detector floating in water. Maybe use that as a picture. What kind of composition would you use? Would you put them in the center? Would you put them at the top? Each of these 3 pictures has a different feeling to them, right? Here, they're drowning and you see the detector more as a mirror image, which is a little bit more abstract. Here, it's a little bit more balanced. My least favorite option here, they've got a lot of work to do. You're looking up and you're going, these 2, you were gonna need more guys. So to end, because I think the idea of aesthetics and the idea of making things look not only clear, and with a power of explanation was a theme with what I said, but also thinking about how things look on the page and respecting negative space and respecting type. And so this question of should science be ugly sometimes comes up. Obviously, this question is, the answer is no, it shouldn't be ugly. Sadly, there's a lot of ugly things around us. If you Google the world's ugliest currency, you will come up with this, which is affectionately called by the Australians clown puke, which is thought to be the ugliest bill on the planet. It isn't pretty. And so you have to ask yourself, does currency have to be ugly? You know, why are we surrounded by these things? What if we Google the world's prettiest currency? We might get this. And although these are artworks, this is not real currency, it does remind us that the real stories are the ones that are best told when you shine a different kind of light on them. With that, thanks so much for your attention, and I'd be happy to take questions in the time that we have. Thank you.
Thank you very much for this really nice talk, giving so many different aspects to the topic. So for me, I do not even know where to start putting my—
Well, you start at the beginning, and then when you come to the end, you stop.
Yeah, but at first I would like to open the floor to the audience and to the other ones. And I would just encourage you to just unmute and talk.
Yeah, please.
I have a question. So how do you spark delight? It sounds easy, but how do you do it? Do you have a couple of tricks or recommendations?
There's no tricks. If I don't find it delightful, I don't think others will. That's not true, though, of course. So as long as I'm delighted, I just take a chance. That's all. I take a chance and I see what works, and I act as if it's sparking delight. And maybe sometimes it's kind of like you fake it till you make it kind of thing. But it's my intention to do so. And even though I'm not certain to succeed, and I don't even know how often I succeed, honestly, because it's not like after every conversation I say, so was that delightful or what? Because that would be weird. I think by thinking about it and by bemoaning the fact that not enough things that I look at spark my delight, I'm a little bit more sensitive to it, and at least it's a priority. So, and what that means is that and I understand the somewhat lighthearted aspect of saying spark delight. What I mean by that is have many layers of explanations. At the core, have the topic you want to explain, have the lesson you wish to teach, have the observation you want to be re-examined. That's the center of the meal. There will be other things that are going to be necessary to make it interesting, because there's a lot of things that are important to know, and people do not have a lot of time necessarily. I, for example, treat my audience as very intelligent, but very bored. In other words, I do not want to waste their time. They do not want their time wasted by me, and they get it. And so I tried to challenge them with a complicated presentation or a complicated conversation that touches on a bunch of different things, but I'm always trying to let them know that kind of their well-being as an audience is on my mind. So I hope that, by including a little bit of poetry, by including things that are not too cliched, by talking about how you feel sometimes, by just referencing emotion, I think that connects you. The pool of emotions, maybe delight will be in there. Everybody will have a different way of doing it. Find your way.
I want to say I really like your work, but I think it's rely a lot on your interpersonal skill. You have to have scientific understanding, artist eyes, and the poetry spirit. do you think it's possible to achieve what you did with a team? Would that be hard? Do you have any
with a team?
advice?
Sorry,
Yeah,
with a team?
with a team.
Yeah, if you have an artist and a poet.
Yeah.
You know what? Thank you. Okay, first of all, I don't know the extent to which I embody these things. I try to think that way, and I just act as if I do, I guess. And I correct myself, and I refine my approach. And every time I talk about some things, if I talk about them several times, I don't have a script, and I don't repeat myself. I shuffle things around, and I tell you how I feel about them based on how I feel about them today. And if something sucks, I'll say it. I'll say that this was a good idea at the time, but now this seems lackluster. Is it possible in a team? Yes, if you if you have a group of people who share common values, which is key. And I don't just mean we like science and we want to cure cancer, because everybody in this building wants to cure cancer. What I mean is the way in which you wish to go about these activities. Will you be kind of emotionally and poetically inclined to the philosophical implications of your activities? You know, the fact that we all are born and die, and in the end it means nothing, right? All of those things. Do you think about those things? Do you want to think about those things? Do you think about those things naturally? You cannot force people, you cannot train people to think about their existential angst. If they don't think about it, why would they want to? Only people who naturally think about it are going to kind of gravitate towards this. I'm Polish, I'm from Poland. I'm the way I am because of the way I was raised in that country. When I speak to people from East Europe, there is a camaraderie around the sadness of life that I don't have to explain to them. In Canada, we don't have this here. I speak to Canadians and they're like, but don't you just want to be happy? And I'm like, no. The point is, that's a joke that I'm saying, right? My answer no is a joke, but they don't get it. And so no, I can't teach them what it means. I can explain to them what it means, but I can't persuade them to be that way. And so I think when you're assembling a team, you should really be looking beyond just the core skills of necessity required by the subject matter, but how you wish people to engage in their work. So some teams I think are going to be more difficult to steer, and some much easier to steer. But you need to find the poet. Whoever's the most poetic, even if they're all non-poetic, there's always the most poetic person. You know, you need to find the scientist if it's not a team of scientists. You need to find a person who will fill that role and act like they do and do the best that they can. But it's hard. It's very hard. All of these activities, these projects were mostly done by myself, and there was an art director in some cases, such as Max Cooper's video. So he was the art director, and we were working on it together, but it was mostly me.
Thank you.
So I would have a question also. So there's kind of this aspect of getting flavor and feeling and emotions and into the communication, and kind of having some questions in mind. So where is here kind of the limit between generating something that's just engaging or something that is manipulative? So kind of the question of being kind of objective, of giving people the possibility to go beyond your interpretation?
Oh, well, there's a huge difference between, because it's the intent. I mean, manipulation, I'm going to take the way you use that word as to mean some form of undisclosed intent. I'm trying to manipulate you to get a vaccine. And so I'm going to show you some pretty graphics of healthy people and ugly graphics of sick people and hope that you'll like the pretty graphics. I wouldn't do that. I reveal my motives. Here's something that's fun to know. Here it is. And here is what I think about it. At no point do I ever have an agenda. Now, yeah, I would love everyone to just start Googling Richard Feynman and having him become their personal hero. You know, but I'm not, that's a good thing, I think. And that's pretty clear because I like him. I think what you need to do is this idea of show the data and let the data speak for itself. The data will not speak for itself because the data is too complicated most of the time to speak for itself. There are people who've been staring at certain data sets forever, and we want their good wisdom in the message. We are going to be shown a path that is a good, let's say, a reasonable conclusion, a reasonable hypothesis, a reasonable interpretation, justifiable interpretation. Then we will be shown a couple of other paths that are possible interpretations, and we'll be armed through their judgment with the tools of how to navigate this complicated web of facts and data and conjecture that we've been presented. It isn't enough to just show the outputs of models, let's say for climate change, and say, oh, well, there you go. They'll just make people draw their own conclusions because they're not skilled to draw their own conclusions. Nobody would say, why don't I just give you a scalpel and let you operate yourself? Nobody would say that. In fact, when we go to the hospital, we are basically held captive to what we assume is the good professional skill of the people in the hospital to perform things on us when we're not conscious. They don't ask us, and we don't want to be part of it. So there are many, many times in our life when we give up what we might think. In fact, we're never even asked, because we believe that other people have much more expertise than we do. And I think that particularly when it comes talking to the public, this has become lost somewhere, that suddenly there's this idea, well, let's include everyone in the conversation, which sounds fantastic. And many conversations should have as many people included in them as possible. But something that is very technical, that requires, let's say, a lot of math and a lot of judgment about and numerical literacy, it might not accommodate a lot of people in the conversation. And so this is where you need to be upfront about it. And you need to say, there's all these people who've done the work. This is what we think. This is our best idea. There are no other viable alternatives that we've come up with. Feel free to have the conversation of what you think viable alternatives are. But those conversations have to be, free of the bias and opinions of the audience as well, because as much as scientists might be sometimes said to not be objective and have a bias, my God, when you look at the conversation out in the public, it is full of bias and it lacks complete and any objectivity whatsoever. So I think what winds up happening is that people are scared that the scientists are really just like the non-scientists who have no objectivity of any kind. And in the end, objectivity is very difficult because there's scientific objectivity, but then there's also cultural objectivity, which I don't think is a thing. How do we exercise good judgment using what we've learned from the process of science? This is a completely different conversation. And I'm not sure that scientists are necessarily the best people to be talking to about it. So in that way, I'm not worried about manipulating people because I don't do it.
No, I was not pointing at you.
No, but what I mean is, if you're not doing it, then I don't think it should even become a worry, that you might be perceived as, oh, great, you'll be perceived as all sorts of things. But fundamentally, if you have a very good story to tell and your passion is in it and you mean well and you wish to make the world a better place, that is enough. And you can avoid all of those hypothetical criticisms of, well, if the graphic is too pretty, I don't trust it kind of criticisms. They're very popular, because they sound good, right? Like, haha, I caught you in the act, right? Yeah, you changed my pie chart, which was crappy, to some kind of an upset plot, which is a little bit too pretty, and it sounds like you're trying to get away with something, right? Everybody likes to catch people in the act of doing something bad, makes everybody feel good. But we just have to work past it. And this will come up over and over again, and I've been asked this question lots of times, and sometimes by people who make really horrible graphics and give bad talks. So I don't care.
Yeah. So I have one question here in the chat. So Joel is asking, do you have any good books or other references about science designs that you would recommend?
Yeah, so I do. I will share the slides and I will add in a couple of books at the end. I would read Elements of Typographic Style by Bringhurst, who is also a poet. I'm wondering, do I have this on my bookshelf? I can't find it now. Elements of Typographic Style. And the reason for that is because typography is at the heart of, I think, all design, because words are fundamentally at the heart of a lot of communication. And typography is a very long-standing art. There's a strong technical component to it, and there's a very strong layout component to it. And you can learn a lot about layout from typography and apply it to other things. And then you can typography is all about a hierarchy of typefaces and a hierarchy of formats. And you can take that hierarchy understanding and apply it to graphics and symbols. It's a very good book. Should read it every year. Read the first Tufte book, Display of Quantitative Information. A lot of his books are more the same, which is basically more of great things, but that's a classic. And then just look at good graphs. There's a lot of case studies out there, and they're all worth looking. There's a lot of really great graphics out there made by people who know what they're doing. There's tons of them. Just keep looking at those and find your own style. Find what speaks to you. There's many great graphics the same way that there's a lot of great music. And if you say, well, what book should I read to become a better musician? You should probably understand some music theory. And then you have to find an instrument that speaks to your heart and then play the crap out of it. Hands-on instrument as long as you can. Figure out some charts or a topic that you are passionate about. I love space, for example. I like making maps. I'd like making maps of space. And just keep doing it. And you'll get better and better and better, and you'll discover a different version of yourself within this process, and you will grow in a way that no book can teach you. There's a couple of technical things like what software should I use and so on. Those are all minor details, and you just look that stuff up as you need to. There's plenty of great tutorials, and just Google it. But what you want to do is you want to start with very strong basis in the approach to the topic. And again, with typography, because the last thing you want to do is take some great design and just slaughter it with some really bad type. You don't want to do that. You don't want to disrespect the letters. That's what I would suggest.
Okay, I think it's now time to close this discussion. So we still have the panel ahead of us where we have a lot of time again to talk and ask questions.